Hello, everyone. So today our notes are going to be over unit rate and better buy. So make sure you title your notes unit rate and better buy. Now, as a reminder, if you feel like I am going too fast in this video, please pause the video. You have the control to pause the video so that you're able to write things down. Please know if I was in the normal classroom, this is the pace I would be going at, okay? So once again, pause the video if you need to write down information. So let's talk about what is unit rate, or also we will see the term unit price. So unit rate or unit price is a rate or ratio whose denominator is 1. So if I want to set up a fraction, my denominator will be 1. So when we see the word unit, unit means 1. Okay, so I'm looking for unit rate, unit price, something like miles per hour. Well, that means for 1 hour. Or for price, the price of 1 Canvas Sprite in a 6-pack. Okay, so hour, 1 are those keywords to tell us, all right, here's unit rate, here's unit price. So here's the good thing. In our last video, we just learned about proportions and how to set those up. Guess what? It's the same steps for unit rate and unit price. So your first step is write a word ratio. What two things are you comparing? So if I use that miles per hour example, all right, miles per hour is what I'm comparing. Set up a proportion and write the first ratio given in the problem. So I would write what I know. All right, here's where it's a little different. Put a denominator as 1 in the second ratio. All right, so instead of filling out what else I know, if it's asking for unit rate, unit price, I know that the denominator automatically needs to be 1. And then whatever's on top is what I am looking for. So the variable would go here. Then step 4, I solve using the butterfly method, which is the same method we used last time, where you would cross multiply and divide. So at this point, make sure you pause the video so you can write all these steps down. Yes, I want you to write all these steps down. You never know when I may ask you to, hey, submit a picture of your journal online. Okay, so go ahead and pause the video to write these down. All right, so let's take look at an example of finding the unit rate for each ratio. So the first example I have is 120 words in 3 minutes. All right, and I want to know how many words per minute. Okay, that per minute means in 1 minute. So this is an example of unit rate. I'm going to start off by writing what I compare. Well, I'm comparing words to minutes. Words came first, so that came on top. What do I know? All right, I know automatically 120 words in 3 minutes. So I'm going to put 120 words on top with my label, 3 minutes on bottom, making sure the top matches the bottom. And then words per minute. Well, I don't know how many words I'm typing in 1 minute, so I'm going to put an X for my variable, or whatever letter you so choose, and then the 1 in your denominator. So this is an example of what your proportion should look like. Now I can go through with step 4 and solve using that butterfly method. So remember, you're going to want to cross multiply the two numbers you see in the diagonal. So I see 120 and 1. Well, multiply 120 times 1. Hopefully we know anything times 1 is itself. So I'm done with that. And then I just need to divide by whatever's left over. And I see that X equals 40 words. So we would say in this situation that our unit rate is 40 words per minute. So using the example above, I want you to try this next problem on your own. 240 miles in 6 hours. So go ahead and pause the video and try this problem on your own. All right, so hopefully you paused the video and you were doing this on your own. So let's talk about how to set this up. So the first thing is 240 miles in 6 hours. Well, I am comparing miles to hours. So I'm going to write my word ratio. Now I need to write, what do I know? Well, I know I traveled 240 miles in 6 hours. Just saying that had to be some traffic jam or something going on there. That's pretty slow. All right, then set it equal to, well, since I'm looking for per hour, I know that is 1 hour. And that, I don't know how many miles that is. And I went ahead and abbreviated because I'm out of room. So this is what your setup should look like. Now, we need to multiply. So if I cross multiply, 240 times 1, remember anything times 1 gives me 240. Then I'm done. And I need to divide by what's left over. Bring down my zeros so it can go into 0, 0 times. Sorry guys, I ran out of room. So I would get x equals 40 miles. So we would say our unit rate is 40 miles per hour. All right, so hopefully you have this written down because now we are moving on. If you don't, remember, pause the video. All right, so the next thing we need to talk about is unit price. All right, it's still going to be the same thing. We're still going to want our denominator to be 1. However, I'm going to change it up. Normally, I tell you whatever comes first, write that on top, except when it comes to price or cost. I mentioned this in the last video, okay? So please make sure you write this sentence down. For unit price, write the price on top of your word ratio. Trust me, it'll make your life a little easier. If you forget, it's all right, but try to remember to write price on top. So what am I going to do? Well, my first example says a 24-ounce jar of salsa for $2.88. I see money, that price, so I need to know price goes on top and the ounces goes on bottom. So I write that word ratio. Then I'm going to write, what do I know? Well, I know $2.88 and 24 ounces is equal to, do I know the cost for 1 ounce? No. So I'm going to put 1 ounce in my denominator. Now I can go through and do my butterfly method. So I'm going to cross multiply. So anything times 1 is itself. I'm done with that. And now I need to divide by what's left over, which is that 24. Now, since I have a decimal underneath, we're going to have to be careful with this. Don't forget to bring that decimal straight up. Now I can go through and divide. 24 can go into 28 one time. 24 can go into 48 two times. So we would say that for the jar of salsa, it is 12 cents. Don't put $12. Remember your decimal. It is 12 cents per ounce. All right. So the next question says 12 gallons of gas for $15.24. Go ahead and pause the video. Try that on your own. The first thing I'm going to do is I'm going to do my setup. Okay. So we're going to check the setup first. So once again, first thing I want you to do is set this problem up. All right, so hopefully you pause the video and your setup looks something like mine. I see money, price, so I know price goes on top and gallons goes on bottom. So then I write what I know. I know is $15.24 for 12 gallons. I need to set it equal to my second ratio. I don't know how much it costs for 1 gallon, so that's why I'm going to put X over 1. Because remember, if I'm looking for unit, okay, I need a 1 in the denominator. All right, now go ahead and pause this video so that way you can solve using the butterfly method. All right, so hopefully you pause this video on your own and you can check your work with mine. Well, I know if I cross multiply, 15.24 times 1 gives me 15.24, and I need to divide by what's left over, and that is 12. So when I divide this through all the way through, I would get it's $1.27 per gallon of gas. So once again, this is basically the same thing we did in the last video, except for we need our denominator this time to be 1. All right. Now we have a star example for you. This is something that has been tested before. So we want to give you a preview as to something what you can see. So it says, a county with an area of 425 square miles has a population of 9,350 residents. Which rate best represents the relationship between the population and the area? Okay, so one thing I want to note is for this example, it already gives you what you're comparing. So we're comparing the population to the area. Population in this means the residents. Okay, so when you write that word ratio, you want to make sure that residents comes first and then the area, which is miles. All right, go ahead, pause this video, try this example on your own, and let's see what you get. Now, before I even go through and set this up, let's read through our answer choices. So A says 22 square miles per resident. B says 9,350 residents per square mile. C, 22 residents per square mile. Or D, 425 square miles per resident. Okay, let's look at this from a logical perspective. I know automatically I can get rid of 2 answer choices. Most questions, you should be able to get rid of at least 1 or 2 just by using logic. You may have seen this already, but B says 9,350 residents per square mile. Well, we know that's not true because our problem itself says 9,350 residents in 425 square miles. So it can't be the same. So B is automatically gone just by logic. Now, I can also get rid of D. Why? Well, it says 425 square miles per resident. Well, we know from our problem is 425 square miles per 9,350 residents. So that can't be it. Well, now let's go through and solve this so we can see, what should be right, A or B? Now, just probably based on, our word ratio alone, you should be able to figure this out. But let's go through this anyways. So I'm going to use residents per mile. You could have used population per mile or population per area. That's fine. Well, what I know that I have 9,350 residents per 425 square miles. I'm not going to write out residents just because I don't have enough room, so I abbreviated it. So I know that in 1 mile, I need to figure out how many residents there are. So if I go through cross multiply divide, 9,350 times 1 gives me 900 3,050. Let me make some room up here. Which means I cross multiply that, done. 425 is left over. So I know that 425 can go into 935 2 times. And that would give me 850. Bring down my 0. 425 can go into 850 2 times. And I'm left with x equals 22 residents. Okay, so now let's look at our answer choices. Well, answer choice A says 22 square miles versus C, 22 residents. Well, just like I said, based on our word ratio, we could have automatically chosen C. So what I'm trying to get at is it's important to write your word ratios because you may be able to find the answer without having to go through and solve all of this. Now, if you want to go through and solve, you should have ended up with the same answer. All right, so that was about unit rate and unit price. Now let's talk about the better buy. You may like this one because it's talking about saving you money. And we like money in 6th grade. You may not have any, but we like having money. And what I mean by you don't have any, it's probably because it's your parents' money. All right, so the better buy. So the better buy is to determine which product is a better buy, meaning find the unit price of each item. So the one that costs the least per unit. Okay, so when you're an adult and you're going grocery shopping and you're on a budget, okay, I can't just go buy anything I want. I need to figure out what's going to give me the better deal. As adults, we love deals. Okay, so I can figure out per unit, all right, which one's the cheapest per unit, and that's what I'm going to buy. So please, in this situation, do not automatically look at something and go, oh, that sounds like a better deal. No. You got to do the math behind it. Okay, so once again, don't choose what you think is the better deal. Do the math, all right, and let the math do the talking, because otherwise you may get it wrong. All right, so I want to know which box of detergent is the better buy. 5 pounds for $4.95 or 8 pounds for $7.36. Well, we're going to approach this the same way. You're going to have 2 different proportions set up. One for your 5 pounds, one for your 8. So remember, since we're talking about money, price, I'm going to put price on top and pounds on bottom. And we're going to start with the $4.95. So for $4.95, I can get 5 pounds of detergent equals to, well, I know that I'm looking for how much it is for 1 pound. So X will go on top. Now I'm going to cross multiply. $4.95 times 1 gives me 1. All right, I'm done with that. Now I need to divide by 5. Bring my decimal straight up. 5 cannot go into 4, but it can go into 49 9 times. 5 can go into 45 9 times. So I get X equals 99 cents. So we would say it's 99 cents per pound. All right, now let's take a look at what would be for the 8 pounds. So once again, I set up my word ratio, price per pounds. What I know it's $7.36 for 8 pounds. And I know I'm looking for 1 pound, how much it costs for 1 pound. So if I do my cross multiplication, that butterfly, $7.36 times 1 gives me $7.36. And whatever's left over is what I divide by, so I gotta divide by 8. And I bring that decimal straight up. Now I can divide. 8 can go into 73 9 times. 8 can go into 16 2 times. So we would say x equals 92 cents. All right, so now I got to look at the unit price for both of these. For the 5 pounds, it's 99 cents per pound. For the 8 pounds, it's 92 cents per pound. So what is less expensive, 99 cents or 92 cents? Hopefully you say 92 cents. So we would say the better buy is going to be the 8 pounds for $7.36. Okay, we like this deal better in the math world. So once again, if you do not have this all written down, please pause the video. All right, so now I have an example for you to try. Which case of juice boxes is the better buy? 4 boxes for $1.60 or 6 boxes for $2.75? So what I want you to do now is pause the video and set up your proportions. And let's see if they match mine. All right, so hopefully you pause the video and you set up your proportions and they look something like mine. Okay, remember we're talking about money, so price goes on top. All right, so now pause the video again and go ahead and solve this. All right, so once again, hopefully you pause this. Let's look at our work. So I know for the 4 boxes, 1 box costs 40 cents. And for the 6 boxes, 1 box costs 46 cents. So remember, ask yourself, in the math world, what would be the better deal? Okay, so which one is smaller, the least? Well, we would say 40 cents is a lot less. So the better buy is going to be the 4 boxes for $1.60 is the better buy. All right, so hopefully you have this all written down. If not, pause your video. And let's talk about our exit ticket for today. All right, so remember, the expectation we have is that you are completing the video and your exit ticket during your class time. Okay, just like you would get on Zoom with us, you should be watching the videos, getting the lesson during your actual class time. If you cannot for any reason, then this exit ticket is due by 11:59 p.m. the same day. Okay, so once again, expectation, complete this during class time. Especially if you're in person at school, you should be working on this. There's no reason for you not to do anything other than math work during math class. All right, getting off my soapbox now. So, your exit ticket for today says you must watch the video and take notes before you complete the exit ticket. If you're seeing this before the exit ticket, congratulations, you did the right thing. All right, you have 5 questions that you need to answer. All right, and these are all very similar to the notes you just took. All right, so please, once again, complete this during class. If you don't complete it during class, then it's due by 11:59 p.m. tonight. And please remember, if you're having issues, Coach Kramer and I gave you 3 different math teachers who you can go to for help. Please take advantage of that while we are away. Thank y'all.